Welcome to the Explainer. Today, we're digging into something that is, honestly, one of the most powerful features in all of AWS, Application Load Balancer rules. This is how you get to control your web traffic with, surgical precision, right at the front door of your entire application. Okay, so here's how we're going to break this down. First, we'll talk about the actual problem we're trying to solve. Then we'll get into the nitty-gritty of how an ALB actually makes its decisions. After that, we'll look at what it can do with those decisions, like forwarding traffic. And then we'll wrap up with some really powerful advanced techniques.
So let's start at the beginning. Why do we even need this stuff? Well, modern applications are complex. They're not just one single program running on one server anymore. I want you to just picture your website, example.com. Behind that one single address, you might have API servers, a different service for handling images, another one for streaming video. It's a whole ecosystem. So here's the problem. You've got one front door, but a dozen different rooms inside. How do you make sure everyone gets to the right place? And that is exactly where the Application Load Balancer, or ALB, steps in. The best way to think about it is like a really smart receptionist or an intelligent traffic director for your app. It stands right at that front door, looks at every single person, every request that comes in, and based on a rulebook you give it, it knows exactly where to send them.
All right, so let's get into the mechanics. How does this smart receptionist actually make all these decisions? It all comes down to what we call the listener's rulebook. You see, every listener on your ALB, and a listener is just the process that's checking for traffic on a port, like port 443 for all your secure HTTPS traffic, has this list of rules. And each rule is just a very simple, very clear instruction that tells the load balancer what to do if a request matches certain criteria. And here's the crucial part, the thing to really remember. Every single one of these rules boils down to a simple if-then logic. If an incoming request looks a certain way, then do this specific action. That's it. This simple structure is what makes it so incredibly flexible and powerful. So that if part is all about the conditions. The ALB can look at so many different parts of a request. For example, it can ask, is the user trying to reach api.example.com specifically? Is the path in the URL something like images? Are they using a GET or a POST request? You can even check things like query strings in the URL or the user's IP address. It's like a checklist for every single visitor.
Okay, so once a condition is met, the if is true, the ALB has to perform an action. That's the then. Let's start with the most common action by far, forwarding the request onto your backend servers.
The forward action basically says, okay, you're good to go. Let me send you to the right place. And that place is called a target group. A target group is really just a collection of your resources, your EC2 instances, your containers that are all ready to handle that request. So a rule might be, if the path is /API/*, then forward them to the API server's target group. Simple as that. Now, this is where it gets really, really cool. You don't just have to forward to one target group. You can forward to multiple groups at the same time and give each one a different weight. This is an absolute game changer for things like A/B testing or doing canary deployments. You could send, say, 10% of your users to a brand new version of your app, while the other 90% go to the old stable one, all controlled right here. And here's a peek at what that looks like under the hood. In this little snippet, you can see exactly how it works. We're defining a forward action with two different target groups, a blue one and a green one, and we're just assigning them different weights. It's really that straightforward to set up a gradual, safe rollout. All right, one last thing about forwarding, stickiness. Imagine a user has a shopping cart. It's super important that all their requests keep going back to the same exact server so they don't lose what's in their cart, right? That's what stickiness is for. The ALB can create a special cookie that basically glues a user to a specific server for their entire session. So forwarding traffic is the main job for sure, but it's not the only trick up the ALB's sleeve. Sometimes you want to handle a request without ever sending it to a server, and that's where redirect and fixed response actions come into play. This table lays it out nicely. Besides forward, which we've been talking about, you have two other final actions.
A redirect tells the user's browser, hey, go over to this other URL instead. And a fixed response lets the ALB itself just send a response right back to the user. Let's dig into those two.
The redirect action is so useful. The classic example is for security. You can set up a simple rule that says, if any traffic comes in on insecure HTTP, then redirect it to secure HTTPS. It's also great for SEO when you move a page and need to set up a permanent redirect. You get full control over every part of the URL. And check out the fixed response. This is so clever. Instead of taking your whole website down and deploying new code just to show a maintenance page, you can just add a single high-priority rule to your listener, a rule that catches all traffic and just returns a simple 503 service unavailable message. It's such a clean way to handle downtime.
Okay, we've seen how rules can direct traffic. Now let's talk about how they can secure it. This is one of the most powerful features. You can actually have the ALB authenticate your users before their request ever gets anywhere near your application.
Yeah, you heard that right. The ALB can integrate directly with identity providers that use the OpenID Connect standard, or OIDC. That includes services like Amazon Cognito, Auth0, or even social logins like Sign In with Google. This means the ALB handles the entire complicated login dance, and your application can just focus on what it does best. The flow is actually pretty straightforward from a high level. An unauthenticated user shows up. The ALB sees they aren't logged in and sends them to your identity provider. The user logs in. The provider sends them back to the ALB with a special code that says, yep, this person is who they say they are. The ALB checks that code, and only then does it forward the request onto your application, now with proof of identity.
So you might be wondering, okay, how does my app actually know who the user is? The ALB takes care of that by adding special HTTP headers to the request it forwards. These headers contain everything your app needs: the user's ID, their access token, and all their user information in a secure format. Your application can trust these headers 100% because the ALB itself added them. And that, right there, is really the big takeaway from all of this. ALB listener rules give you this amazing control plane that sits completely separate from your application code. You can do A/B testing, enforce HTTPS, put up maintenance pages, and even handle user logins, all just by changing configuration without ever deploying a single line of new code to your servers. It fundamentally changes how you can think about managing and deploying your web applications. It gives you this incredible amount of power and flexibility. So, the only question left is, now that you know you can control every single request right at the front door, what will you build?